Hi, I'm going to go through a simple profit maximization example. And here's the equation for profit maximization with respect to X. And X is the price, and we're trying to maximize the profit. So to give you an example, how I could graph that, I put the price down in the C column and the profit in the D, and I derived the D profit in the D column. Look, I can show you the equations written in here. I just plugged into that equation, and you can pretty much see where the maximum profit occurs between 8 and 9, which is 8.5. But let's use some calculus. Well, first of all, before we go there, look at the graph. You can see by just following the graph up that profit is maximized at about 8.5. This is the greatest distance between the x-axis or price line and the profit using the above assumptions. And one quick caveat, I do not like to use the word profit because profit to me is an unexpected increase in wealth. This is an accounting type profit. We're just taking revenues minus cost. And later on we'll talk about wealth maximization, where we take more than just one period but multiple time periods and we do discounting. Anyway, so you can see here that the line that's just tangent to the very top of the curve will be 0, the tangent line. So we take the first derivative and we come up with minus 800 plus 6,800. And we now want to solve for the derivative where P equals 0. So we've got 800x equals 6,800, x equals 6,800 over 800. And we see that this solves for 8.5. So I hope that that makes some sense. And I have to ask you a question. Is this a price taker's market or is this a price seeker's market? Anyway, I'll write out some of these equations in the next part of this lecture. Okay, we'll look at another graph and give you a chance to figure out how to take the derivative of the profit maximization in the first part of this lecture. So let's take another example and find the slope of a graph where y equals 2x raised to the square, or square second power. And we know that we just can multiply 2 by 2 and make it 4 and take 1 away, and it's 4x. We know that. We can do that. But why not just go through one simple example? H is delta or small change. So the Newton quotient is simply you take your function and you add in the small change and you subtract from that your original starting point and you divide by the change. So you want to find out exactly how much you've moved, in a sense. It's like any other quotient. So I expanded this equation. You can see these steps here. And then I finished up with 4x plus 2h. And as h approaches 0, you can go through these steps to the expand them. As we find out that the derivative equals 4. And so if f of x is 3, then 4 times 3 is 12, which is the slope of the line. And here I show you where I just graphed it out here. And I should have the graph down here somewhere. And you can get, wait a minute. Yeah, there it is. It's slow coming down. Oh, there, because, okay, that doesn't look too good because doing it with the screen capture movie on, it's hard to operate your own your Excel site. Anyway, try that, see how it works out, and then figure out how we got using the Newton quotient, how we got the slope of the profit maximization line in the previous class.